additional support team, right? And apart from that, there might be some cases of some illness, some other issues. So I had seen multiple accidents even in my shift. So keeping everything in mind, we have to take the decision which should be the most optimal decision. So I should not be overspending, but at the same time, I should not be taking a higher degree of risk. So let's understand that. So as we have rightly said, is probability talks about the chance, right? Or how likely a event can take place, right? The certainty of an event. But this call, when you take again and again, and when you look back at your historical states, right? How correct you were or how incorrect you were in terms of taking a decision related to your choice with regards to the chance. So then we call it as the distribution. So probability, what it does not tells you is the impact. It only talks about the chance, but when we are dealing with the impact, right? So we have to go a step beyond what we have studied in the probability classes. We have to look at the distribution, right? How? So it's a game when you have taken a call. Just the IPL got over yesterday. So based on your call on head and tail, so how many times you have rightly called a head and you had won the toss, and accordingly you have taken. So if you're calling the head multiple times, but what is happening that the coin is giving more number of tails, so you have to think differently, right? So after that, you should think of calling a tail also later on, because you're losing the toss, right? And when you're losing the toss, it's impacting you, right? In some way where you had thought that I will take the first batting or I will take the second batting, but you never got that option because you lost the toss. So that's where the probability distribution is more important from the decision maker's point of view compared to just look at the probabilities. Okay, so that is what we are going to learn here. So we are talking about the outcomes of those events, right? So it's not just a single event that we are looking at. We are looking at how, if we combine several outcomes together, and how best we can use it for decision making in future or in current state. That's all about this probability distribution. So let's start, because when you will learn about all this model building, right, different AI and ML tools, right? All these tools, how a machine learns. We talk about machine learning algorithms, but how it learns, what really trains the algorithm. Have you studied about any of this AI/ML algorithms?
Some of them regression,
Yeah,
name,
regression. Yeah, regression is a
classification.
very basic algorithm. So how regression works?
So regression is the measure of uh, the dependency of one variable upon an independent variable.
Okay, and why do we need to look at this dependency?
Because there could be certain factors which could be affecting our subject of interest.
Mhm.
So by how much we need to have some measure to it. If it is impacting, by how much
Yeah,
and how it is
and
impacting.
how we get the data, from where we get the data?
For regression,
Yes.
I mean, there could be multiple sources. What?
Yeah, but those sources have already got the data, right? So
Hmm.
I'm using the historical data
Yeah.
based on what has already occurred, right? So let's see, like I'm teaching you a course, and the amount of time that you're spending in this class. Okay, so that time has any relationship with your performance in different tests. So if you want to just check whether it makes any sense to attend a professor's session or not, You can always look at the historical data. You can see how many sessions you have attended for various courses and how the marks, because marks is the outcome variable, yes, which is a dependent variable on the duration or the time that you have spent, which is the input variable. Okay. And that's where you have developed a model which is helping you to predict or helping you to take the decision for future. Should I really spend my time in attending a professor's class, or without even attending, if I'm getting good marks, so why should I spend my time sitting in this classroom rather that I can spend it preparing myself for the exam and so on. Clear? So probability distribution is about all those historical relationships that happened between an input factor and an outcome factor. Okay, so that is my X and Y. And we are using it for some future predictions. So it could be predicting the risk of future. It could be predicting of forecasting your sales, forecasting your manpower. The example that I gave, the shift bandwidth that will be required. That's what I was forecasting or predicting based on my historical workloads. So anywhere where you have to come out with a decision, and this decision should be having lesser degree of uncertainty and higher degree of certainty. There you have to study the probability distribution. Okay, so you're using the historical information. Take the very simple example of the stock market. So why do we look at what has happened with this stock in the past 1 month, 3 months, or 9 months, or a year? Because we want to understand the trend, how this specific stock has performed historically, right? That can give me the probability of making a higher value or higher return on the investment on the stock, or a lesser return or a negative return also. Clear? So those are the real application of the probability distribution, and most of the models, right, are stochastic in nature, means which are probabilistic in nature, because you cannot have a very deterministic value. Even if you are using a regression, it will give you a single value. But what we do, along with that value, we ask how confident you are in this value. So you will study the significance factor, or if you have not studied, we will discuss that. So significance factor is something which tells you what is the degree of error in that, or what is the chance of error in that forecast. Okay, so no manager or no forecaster will give you the exact value. It will always say that this is the possible value and this is the level of confidence I have with this value. Okay, so we will see all this as we will go through this discussion. So for understanding the probability distribution, we should be very clear with 3 different concepts. One is the concept of random variables. Second one is, or the second part of it, are the 2 types of probability distributions. One is the discrete probability distribution, and the second one is continuous probability distribution. We'll learn what they are. Any idea what we mean by a random variable?
Any variable of interest that we want to find the probability of.
Yeah, so variable is which varies with one incident to another incident, right? As we will run more experiments, we will get different results. But a random variable is something where we cannot really predict what will be the outcome of the experiment. Okay, so a very simple example I'm just telling you here is when you're reading a book. Okay, so when you're reading a book and somebody asks you how many characters you can recall who are part of the book. So as you will move ahead with the book reading, you can recall more and more characters, okay, who are part of the storybook or whatever that you're reading. So here there is a relationship that you are finding, a trend that is coming. So that variable that we are saying, the number of characters in the book that you are identifying is not random, because the values are in one direction, it's increasing. So random variable is something where it can also decrease. So it could take any value. So it's not necessary that it should be on positive side. It will show the increase or it will show the negative side. And if it's not changing, it's a constant. So it can't be called as a variable. So the probability distribution, right? When we talk about this, we are dealing with all random variables. Okay. So it's not a sequential variable where you are finding those values in some specific order or some specific sequence. In a random variable, you cannot really predict what direction the values will move. It can go up on the upward direction, it could go on the downward direction. So example of a random variable is your stock price, which can go up, which can come down. Same way, a country's GDP, which can go upwards direction, which can come down, the price of any product. Those are all examples of random variables. But if you look at the population of a country like India, it can't be a random variable because it's moving on a specific direction. Okay, so we can be having a higher degree of certainty in such variables. But as a decision maker, you will not be hired to take decisions related to such kind of variables, which are quite deterministic and where you can easily predict the values, right? So you will be hired for predicting the outcomes of the random variables where the things are changing in different directions. So for all such requirements, we should be good with the understanding of probability distribution. So first we will start with the random variable examples and how we identify the standard deviations or the means of random variables. Then we will move ahead to the different types of probability distributions. And within those different types, we can classify them into discrete probability distribution and then continuous probability distribution. So the discrete probability distribution are those probability values which are integer values. Like when you're looking for quality testing in any automobile company, so out of every 100 cars, how many defective cars you are identifying? You cannot have 2.5 defective. It's either 2 or 3 defective cars. So that is a discrete probability distribution. So one day you're finding 3, the other day it can go down to 2, the other day it can go up to 5, 7, 8. So either of the side it can fluctuate. So that's where the value of the outcome that we are seeing here, that is the number of defects, is a random variable, or number of defective cars is a random variable. So that is a discrete probability distribution value or variable. Now come to the continuous probability distribution. Now in the continuous probability distribution is the same thing when we are talking about a car. So in that car, if the car, let's take the very simple example of the air conditioner in the car. So if the air conditioner is taking a longer time for cooling, so that is a defect, right? So it's a one-sided thing. But if it's cooling very quickly, so definitely it's taking a lot of your battery. So that is also a problem. So it can take something like time value of 3 or 30 seconds. Let's say it could take 40 seconds, 45 seconds, 50 seconds. So any of these values, right? So there is a continuity. So time is a continuous variable, right? It's not discrete. We can have like 40.1, 40.2 seconds also, and so on. So wherever you can have, or you can fit decimal values in between. So those are continuous probability distribution. Where you cannot, there is the discrete probability distribution. We'll see more cases of that as we'll proceed. Let's start with the random variable. Random variable is a numerical description of the outcome that we are getting from event. Sorry. So what is the event here? Event is any work or any daily work that you are doing. Sometimes we call that as a experiment. So an experiment is something which is new, which is undone. So you're doing it on a specific day. If you go back to your science classes and so on during the undergraduate and school days, we used to do a lot of experiments in the chemistry lab, in the physics lab. So what that means, experiment can give you some unique outcomes. Not every experiment or every person who is doing the same experiment will get the same outcome, even though that is desired, but it can give different results. And that's why we call such results as random values or random variables. So the two results can be same also, they may not be the same values. So that's why wherever there is a chance of getting more than one values as an outcome, we call such events as experiments. Okay. And when the outcomes are not same for everyone, it's a variable, and this variable could be on different sides. It could be higher for someone. If the values could be lower for someone, then we call such variables as the random variable. Now, as we said, and we have already discussed what are discrete and continuous random variables or probability distribution. So a discrete random variable can assume a finite number of values or an infinite sequence of value. So there is no limit how many values it can take. So it could be on either of the sides. It can take a very large number of outcomes. It could also take a very limited number of outcomes, but it should have more than one outcomes. If it's not, it's a constant, right? It can't be a variable. So it should have at least two or more outcomes. Then only we can call it as a random variable. Otherwise, it's a constant. So a continuous random variable may assume numeric values within an interval or a collection of intervals. So the examples we have already seen time as a variable, same with the weight, the distance, the temperature. So anything which can take a decimal values are part of the continuous random variables, which normally has a unit along with it. Whereas in discrete random variables, you will not find the unit values. So there is no unit. It's only a frequency value. Okay. So anywhere you're just counting the frequency or the number of occurrence, that is a discrete random variable. Anywhere where you have a unit which is associated with the variable, that is a continuous random variable. That's how we can remember this. So let's see how we deal with the probabilities of such random variables. A very simple example, a hypothetical supermarket with the name XYZ Mart. So for 100 days, okay, they have just done a frequency distribution table here. So out of 100 days, on 5 days, there were 101 visitors. On 7 days, there are 102 visitors. On 8 days, there are 103 visitors, and likewise. Okay, and total there are 100 visitors. So these are the frequencies of this specific number of customers who have visited to this store. So if I want to convert that into some probability, so how to convert? This is what is called as the relative probability. Okay, so the relativeness. So here, what is the chance of 101 customer visiting to the store? It's 5 in 100, right? So that's how we call it. 5 in 100 means 5 by 100, which means there is 5% chance of getting 5 visitors to the store. Same way, if I have to ask what is the chance of getting 109 visitor on a specific day, So it is 10 by 100, which is a 10% chance of getting this number. So that's how we convert the frequency values into the probability value. And this entire thing is the distribution of the probability or the chances. And just remember one rule, that sum of all possible probability values should equal to 1. If it's not coming, then somewhere you have missed out one of the possible outcomes. Okay, so that's why if you add all these probability values, you are going to get 1 as the outcome. Clear? So let's see how to calculate the mean and standard deviation of this probability distribution, right? So what is the average number of customers that I can expect on this place? Okay, so how to calculate that, we will see it. Okay, so this basically, if we plot it right using a bar chart, this is how the distribution looks like. And further, if you see, sorry, I have not calculated it. We will see with another example that. But these are some of the examples of the random variables. Family size is a discrete, and because family size doesn't carry any unit, but distance of a place from your home, that carries a unit. It could be meters, it could be kilometers, feet, yards. So that's why it's a continuous. Number of pets you have, again, there is no unit, so it's a discrete random variable. So all this is known. 1 minute. I think we have missed it. Okay, so we will do it. Okay, with this example. So two important things that you should remember when we talk about this probability function. So probability function is f of x is the y, whatever you're predicting. So that is your outcome variable. Okay, so the outcome variable's value is what you're predicting based on some input variable. So the outcome, the chance of an outcome should be 0 or greater than 0. It can't be negative. That's the first rule. Either there is no chance or 0 probability, you can say, but you cannot say there is a negative probability or a negative chance. Yes, so every probability value should either be 0 or a positive value. And when you add all the possible outcomes or all the possible chances that you can have from the experiment, it should give you a value of 1. So these two are the universal rules with respect to the probability distribution. Irrespective of it's a discrete probability distribution or it's a continuous probability distribution, these two rules will hold true for both of them. Okay, so then this f of x, when we deal with the discrete distribution, we call it as discrete probability function. When we deal with a continuous distribution, we call that as probability density function. Okay, so that's one of the tricks of understanding, right? In the exam, you might get a question and you may feel confused between whether it's a discrete probability function that you have to calculate, or you have to calculate a continuous probability function. So normally when you are asked to calculate the probability function, if the word probability function is it's written, it means the distribution is a discrete distribution. Okay, so for continuous distribution, it needs to be written as probability density function. Okay, it can't be, because density means the density. So because it's an interval, within that, how much is the intensity or the amount of chance that falls there. So that's why we don't call it as probability function. We rather call it as probability density function for continuous. But when it comes to discrete, it's called as a probability function. A simple example of something very similar what we did. These are the number of units which are sold on different days. The total number of days is 200. So we calculated the f of x value here. So that is the probability distribution function. So the chances of 0 units sold is 40. The chances of 1 unit sold is 25%. The chances of 2 units sold is 20%. The chances of 3 is 5%. And the chances of 4 units sold is 10%. So if somebody comes and asks you on any particular day, what is the average number of units that you can expect to be sold? Because we always deal with the averages. Yes, as a decision maker, I have to think from that point of view. So what is the average? We have seen that in the first few sessions, right, where we learned about the measures of central tendencies. So when we are dealing with a probability distribution function also, we need to identify what is that measure of central tendency. And we normally don't talk about the medians or modes here. We talk about the mean, or we don't call it as mean, rather we call it as the expected value. Okay, so expected value is the most possible value that you can expect to happen on any specific day. So this part we know. So now how to calculate expected value? So f of x you have got here. So multiply this f of x with respect to the x values and take the summation of it. You will get the expected value, and that is the mean of a probability distribution. Okay, so that is the central line across which you will find the things are divided equally. Let me just draw it here. So basically, if you say that this is what is the distribution, so this E of x is the part which divides the distribution into two halves. Okay, so we also call it as the mean. Yes, so that's how we get it. So the chances you can see here, because this is my probability, and the highest probability is at this point. Yes, so it's gradually increasing up to this value and then it's falling. So that's why most decision makers will stick to that number, even though you may not find this value 1.2 here anywhere. Yes, that could be a question, right? Because this is 0, this is 1, this is 2. There is no value really which is 1.2, because these are all discrete values. Yes, so when these values are discrete, how I can say that my expected demand is 1.2 units? But that is what the mathematics says here, because we are converted a discrete value into a distribution which is continuous in nature. So we can say that this value is close to 1. So I can keep a stock of 1. So what is happening here? Below 1, the value is approximately 65. Yeah. Or if you can divide this 1 into 2 halves, 12.5. So 40 plus 12.5 is 52.5, is approximately this side. And the balance is the chance of this side. Okay. So that's how this expected value, what really it means is the value which is a kind of a central tendency in a probability distribution. And how it's calculated, you have to first find the f of x, that is your probability distribution function for all the values. How it's calculated, f of x is equal to x by sigma, the frequency of x. is this value. Just a minute, I'm just correcting it. So how I got this as 0.40? So this was the frequency F value. Okay, and then we will have something as sigma F. So each value will be the corresponding F value F0 by sigma F will give you this. So 40 by, or sorry, it was 80 by, let me just check you what is the value, 80 by 200 if I'm not wrong.
Sir, 80 by 200.
Yeah, so 80 by 200, that's how we got this value. Yes, so this is how we will get those values, okay, for each one. So this is again 50 by 200, 40 by 200. So like that, we have got all these values. So this f of x, when you're multiplying it with the actual original phase values, okay, then you will get the chance. So obviously, when anything which is multiplied by 0, it's 0, right? So here you are not getting any return on this 0 sales. And like that, we just got the value, what is the expected value on any particular day, which value will have the highest chance, that is 1.2. That's where we have plotted this line. But we should not just take the decision based on the expected value only. As a decision maker, we have to look at two things. Just we have studied, right? There is a measure of central tendency and then the measure of variability, the dispersion. So now we'll see how to calculate the dispersion here. Okay, what is the standard deviation of this entire distribution? Okay. So how to calculate? We have got the mean value, right? So mean will help us in calculating the standard deviation. So this x bar is nothing but the expected value. Okay. So just for simplicity, I've written it here, x bar. So x bar is my mean, that is the expected value. And the process is same, how we have studied or calculated the standard deviation, same thing we are using here. So first you have to calculate the variance and then you have to calculate the standard deviation. So first look how each value is deviating from the mean, but because it's equally deviating from the mean on either of the sides, so I don't want that to be cancelling out. So you've taken the square of it. Yes. And after taking the square of it, we have to multiply it with f of x, just like during the mean calculation, we have multiplied it with f of x. Multiply and take the summation of it, because these are the weighted average. Basically, here we cannot give the equal weight to everything because some has a higher chance compared to the other values. Like 0 has a higher chance, so we have given a higher weight to 0 compared to 1. Okay, so that's how. If you go with the original formula of the calculation of standard deviation variance, where we are dividing by n. So n is, each one is getting equal weight. But here we are not giving them equal weight. We are converting them into unequal weights. And that's why we are multiplying, because each of them is already divided by n. How we got this f of x? It was already having the denominator 200. That is n. So it's the frequency of this specific value and we have divided n, right? For each of the value, this n is already divided. So basically, you can take the common value here. You can put that 200 at the bottom and you can multiply with these values and then take the summation and then divide it by 200. That will also give you the same answer. Or you can do it here itself, f of x, and you have got the weight, which is in a probability form, and you are multiplying with it and you are getting the variance. And when you're taking the root over this variance, you're getting the standard deviation. So now I have to take a decision here. I can see that mean value is also 1.2 and my standard deviation is also 1.2. So what it can say that I can have a sales of 1.2, but there is a high degree of chance that there will be no sales also, because that is the standard deviation, 1.2 value. So one extreme, if you subtract this 1.2 from the mean, you can have a zero value also. Okay. And towards the other side, you can also expect that the sale could be around 2.4 also, the double also, right? Of what I'm expecting. So there is a very high degree of dispersion on this. So what I can say about a model here, if I have to develop a model for predicting the sales here in this kind of a setup, I'm very sure that a single model cannot really give me a very high degree of accuracy in terms of prediction, because there is a very high degree of randomness in the outcome that we are seeing here. Clear? So now we will come to the probability distribution, right? So we have seen the random distribution. Now, when we talk about the probability distribution, so there are two types, as I have already said. It could be a discrete distribution, it could be a continuous distribution. So discrete distribution starts with Bernoulli's distribution, then we have binomial distribution, then we can also talk about something which is called as a Poisson's distribution, or even hypergeometric distribution. But in your course, we are just limited to the binomial distribution, right? So Bernoulli's distribution is something which is only on theory, which is not very practical in nature. And same way, Poisson's and hypergeometric distributions are there, but not as common as the binomial distribution. Okay. So we'll understand what is binomial distribution. Same way, when we'll discuss about continuous distribution, there are a variety of continuous distribution, which starts with the uniform distribution, then we have normal distribution, then we have exponential distribution, but your course only focuses on the normal distribution. So we will discuss about normal distribution. So one discrete distribution, that is binomial distribution, one continuous distribution, that is the normal distribution. That's what will be the focus. But again, from the exam point of view, you can expect any of the two questions, right, based on what questions are picked out of the question bank for you. So you might get a binomial distribution question in the term, and you might also get a normal distribution. So how to identify it is a binomial distribution problem and it's not a normal distribution? That's what we will try and understand in this session. Okay. So that is one of the learning objectives of this session. By end of this session, we should be clear on that. So let's start with the binomial distribution. As I've already said, this is a discrete distribution. So whatever values which are given. So one of the ways of identifying a binomial experiment or binomial numerical or binomial problem is, so look at the variables which are used in the question. If they are using kilometers, they are using kilograms, if they are using meters, something which can have a unit with it, a temperature or so on, it can't be a binomial. It will be a normal distribution. But if you are seeing the variable like its number of defects, its number of students attending a class, or the marks of the students, which can't have a unit with them, then there is a chance of it to be a binomial distribution. Okay. So that's the first filter when you understand. So what really makes it different from Bernoulli's experiment is Bernoulli's is one-time experiment, whereas binomial is multiple. So when you write 8 or 9 IAs or multiple internal assessments, and you're trying to predict what is going to be the next highest mark based on that. Yeah, so it's a discrete outcome because we don't give you decimal marks. It's either 7, 8, or 9. So it could be a binomial experiment there. So here we have multiple steps. It's not one time. So that's why decision makers, they don't go by the Bernoullis, because there we don't have any historical value because it's a unique thing that we are doing. But binomial always has a sequence of events, right? So where one can lead your next level of decision making. So the four properties of binomial experiment is the experiment consists of sequence of n identical trials. So the trials, you cannot differ. If you have, I gave you the example of the internal assessments. So each internal assessment should be of 10 marks and it should be set by the same professor for the same set of students. Okay, so that's what is the experiment. So they are all identical trials. So you're given the same time to complete the exam. You are given the same resources, same platform. Yes, so everything is same, but it's a new chapter for which you are attending the IA. The two outcomes are possible here when we talk about binomial. So one is the success, one is the failure. So that's how this is called as a binomial, because you can pass or you can only fail here in this from the name. Okay, so that restricts this binomial distribution here. You can't have more than two outcomes. So even though I can get the discrete values 7, 8, 9, I have to convert that into the pass or fail or success or failure. Okay, so that is the second property of the binomial distribution. And the third property here, the probability of the success is denoted by the P, and it does not change from one trial to another trial. So there is one more unique thing. So many of you might argue with me that how that's possible, but it's just like the toss of coin when we discuss that, because the coin might be biased, but we are assuming here it gives the chances of head the same every time that you're tossing the coin, and it gives you the same chances of tail every time you're tossing it. So that is another thing. So the probability values will not change from one experiment to another experiment. So the chances of getting anything or a specific value will stay constant throughout your entire series of experiments. Okay. And the last thing is the trials are independent. So one trial will not influence your next trial's decision. So you all, Harshita, okay, you're the only student. So we have got a request from our support team that you have to fill the feedback. So before we
Yeah,
move
sure.
to,
Like you can fill it whenever you want. It's just don't
okay.
miss out. I mean, like it's okay if you fill it now or
Yeah,
later.
I
That's
think, yeah,
fine.
let's fill it now.
Because only one learner is there, no, so I'm not sure when the call will get ended. So that's the reason
Right,
I
right,
popped in
right.
between.
Harshita, please, you just fill it and then we will move to the next. We will see
Thank
some
you. Thank you so
example of
much.
that.
Thank you so much, sir.
Yeah,
Okay, sir. I just filled out.
right.
Sir, is it possible to wrap up by 9:15?
Sure, sure, sure. No problem. Yeah,
Actually, I have a meeting at 9:30. So,
we will, we will. I will do it. Yeah, no issues. Sure.
and sir, will this slide be available to us?
Uh, I will just see if it's not shared. I will ask them to share it. Okay. So
Sure.
tomorrow I will definitely I will ask them. Okay.
Okay.
once it's done, just let me know. We'll proceed.
Yeah.
Okay.
That's it. I filled up the form.
Okay, great. So now we are talking about the binomial probability function, right? So what is the chance of getting a value in a binomial distribution? If you're given a distribution and you're asked to find what is the probability of X successes in this out of N outcomes. Okay, so for that, this is a formula which might look a little complicated, but not so difficult to remember. Have you studied permutation and combination anytime?
Yeah.
Yeah. So this is a combination basically. N factorial by X factorial into N minus X factorial. So where I'm looking for X combinations out of N possible choices that we have. Okay. So there are N items, but X is my success. So just think about, there are the very classical example that I'm saying, how many cards, 52 cards or something in a game. And in that, if I get the king, I will be the winner. So there are 4 kings, right? Out of 52. So N is 52 and X is 4. So what is the chance of getting this king out of those 52 cards? So this is how the various combinations which are possible. The first part is just for selecting, because we have to do a selection. Yes. So once the selection is done, you are looking for the probability of success and the probability of failure. You're just multiplying it with that. And that's it, what the binomial distribution is. So remember the combination formula, which is N factorial by X factorial into N minus X factorial into the probability of success to the power of the success value, that is 4. When we take the example of the 4 cards out of 52, the kings in a pack of cards. And what is the chance of failure? The probability of the failure into the number of cards which carries those failure values, that is N minus X, which is nothing but 52 minus 4, that is 48. Clear? So simple to remember. We will see one example now quickly on this. One question here. Anyway, this we know that X can't be continuous variable because we are looking for the number of kings or something like that. So let's start with this example. So Rahul is a HR manager and he has a real concern about the low retention rate of employees. Okay. So in recent years, the management has seen a turnover of 10% of the hourly employees. So all those who are the contract employees that they have taken, so every year around 10% people are leaving the organization. So that's for any hourly employee choose at random, right? So if you are randomly, if you're picking anybody, the probability of him to leave the organization is 0.1. Yes. So that much we are clear. So now the question is, using the binomial probability function, if 3 hourly employees are picked at random, it's random, right? So what is the probability that one of them will leave the company? So the situation is there are different teams which are working here in this company, and in the teams there are three employees. Okay, just assume that they are part of it. Three temporary employees are part of each team, and if one person leaves out of the three, there is a high degree of chance that the project is going to fail, right? Because you cannot fill the person very quickly, and that can impact your project. So now you want to understand what is that chance of such failure here in this case. So now let's identify those values, some values here. The very first value that I have to identify is what is my N? What is the N here in this question? Archita, I just need your help.
Number of trials.
N is 3, right? So I'm picking 3.
Okay.
Right?
3.
So that's how we got 3 as N. And for whatever value we are looking for the probability, that is my X. Because we will be calculating f of X. So X is 1. So I got the N, I got the X. Now I have to find the P. And then the Q value. So what is P? Already we have got the P here. Because I want to identify how many people are leaving the company or what is the probability of leaving. So my variable or the check variable is somebody who is leaving, right? So that is my success variable, successfully identifying somebody who is leaving. So that's why we are taking the P as 0.1. And the probability of failing to identify that if P is 0.1, that is 1 minus 0.1. So Q is 0.9. Okay, so now what I have to identify, I have to find f of X equal to 1. What is the probability that one of the 3 selected team members or the employees is going to leave the organization? So for that, it should be n factorial, that is 3 factorial at the top, divided by x factorial, that is 1 factorial, into n minus x factorial, that is 3 minus 1, 2 factorial. Now I have to multiply it with, first will come P, that is 0.1, to the power of
1.
X, that is 1, into Q to the power of n minus x, so which is 0.9 to the power of 2. So if we have to solve this, we will get the answer. So 3 factorial can be written as, we can write 3 factorial equal to 3 into 2 factorial.
3 into 2.
Yes. So in the numerator and denominator, we have 2 factorials. Here 2 factorial and this 2 factorial will get cancelled out. 1 factorial is nothing but 1. So 0 factorial is also 1 and 1 factorial is also 1. So this will be 3 into 0.1 into, this will be 9 into 9.
0.81.
0.81. 0.9 into 0.9 will be 0.81 or 0.081. So just check and let me know. Will it be 0.081 or 0.81?
So 0.81.
Yeah, fine, great. So you're going with that. So when we multiply this 0.81 with 0.1, this will become 0.081.
Hmm.
And when we multiply it with 3, so what will happen? 8 into 3, 81 into 3 is somewhere 24. So 0.24
0.2.
approximately, yeah. So what it says that there is a 24% chance that out of these 3 people who are selected, one is going to leave the organization. So what I have to do as a decision maker, I have to keep a 24% people's bench strength. Okay, if it's IT company or so. Clear? So as a decision maker, what it means to me. Okay, let's see if we have done it correctly or not. So 24.3, right? So 0.243, that's what is the value. Clear, Harsita?
Yes.
Now, a little more one. So Haris is in charge of an electronics section of a large departmental store. And what he has noticed is the probability that a customer who is just browsing. So it's something very similar to Amazon or Flipkart. So they browse through the entire system or entire portal. And then after that, they make a purchase. They may not also. So just think this is a company like something similar to Infibeam, which is exclusively into electronics products sales. So there will be analysts whose job is to really track these customers. And then you have to create reports why X customer who spent so much of time didn't purchase the product. And accordingly, you have to repositioning or do the STP, segmenting, targeting, and positioning of the product, and so on. So now here, he has noticed that the probability that a customer who is just browsing will buy something is 0.3. So that is a chance. Somebody who has come and is browsing, so if he's spending for some limited time, there is a chance that, or 30% chance that he's going to buy that specific product. So now the question is that 15 customers are browsing in the electronic section each hour. Then what is the probability that at least one browsing customer will buy something during a specific hour? At least one is the keyword here.
At least one.
Okay. So how many are there? 15 customer. So in this case, for me, the success is one customer, means the f of x value, or the probability value, p of x, whatever I'm looking for. For 1 is also success, 2 is also success. If 2 also buys, it's good for me. Even if 3 buys, still it's good for till 15, right? Because there are only 15 customers who are there in the specific hour, right? So that's what this question is saying. What is the probability that at least one means this is the least value. Even 2 is falling in this specific interval, even 3 is falling, 4 is also falling, and so on. So this kind of problems can also be solved using normal distribution. We will see that. how it would be in later part, but this is a discrete value, right? So 1 is discrete, 2 is discrete, and the chance of each one buying is same. So that's why it's a binomial distribution, right? So the first customer buying or the second, third, fourth, all the 15 customer buying is having the equal probability or chance. So the problem here is if I use the same formula that we used, I have to calculate how many times this f of x value, or how many times I have to calculate the this function, the probability distribution function, 15 times. So by any means, I can reduce it, my amount of effort. So what I can do is I can calculate for f of x is equal to 0, that none of them is going to buy out of all 15. So, and the minute I add this 2, I have all the possible outcomes, right? So the sum of these two values should always be equal to 1. So what I can do is I can, if I want to find the probability of this part, what I can do, I can look at the probability of this part and then subtract it from the 1 and 1 minus this value. This entire thing can give me the probability for all this value together. Okay, so that is easy. So let's do it here. And after that, I will show you on Excel. Have you studied on Excel how the binomial distribution is calculated?
No.
I think it should be. I'm not sure because binomial distribution is part of that async component. I will show you on Excel how we can do this parallelly. Okay, after this. So now here, let's try and understand what is my n here. N is 15. My x, because I'm just doing this one. X is equal to 0. I'm not calculating all this. So my x is 0 here. My p is 0.3. And q value is 1 minus p, which is 0.7. So we will substitute it in the formula which says that f of 0 equal to 15 factorial divided by 0 factorial. 0 factorial is 1 into 15 factorial. So basically this will cancel out. So this has no real value or real outcome. This will be equal to 1 into, so we have the, what is that? P and Q. P is 0.3. 0.3 to the power of x, which is 0. So anything to the power of 0 is again 1. So this also is of no value. This is 1, this is 1. So basically we have to calculate this 0.7 to the power of 15. So, which is a slightly high value if you can find it in the calculator or in the Excel. We will see it in Excel and then I will show you that itself. Okay, so let me just open the Excel spreadsheet quickly. Or if I have to, or let's do it on Excel and then we will come back to see it.
Sir, in Excel, how do I calculate power value?
I'm just showing you that. We use the hat.
Hat.
So along with the 6, there is a hat, right?
Yeah.
Between the percent and ampersand and. So you used to like, it's 0.7 power 15. Then I have to use 0.7 hat 15.
0.0047.
Okay, so that's the answer, right? We got. Fine. So we did this, right? So equal to 0.7, this at 15. Yeah, great. Now, if we want to use the proper binomial distribution, so we have this function also. So I'm just doing it here. Equal to binom this. Okay, so this is a function. So if you have any difficulty in understanding what are those 4 values that it's asking, click on f of x. This will open. You can easily find what it says. First thing is the number of success in the trials. So number of success in the trials is my x value. I'm looking for 0. I'm looking for 0 success. So how many trials I have? I have 15 independent trials. That is my n value. I will put 15 here. Probability, because it knows what is q. So if I can give only the probability, it's fine. So it's 0.3. Okay. So when I'm looking for discrete value, I will say if it will ask you a logical value. So if you are looking for the cumulative, it's true. If you're not. So for cumulative distribution function, use true. And for probability mass function, just one single value you're looking, use false. So I'm just looking for a single value. Okay. Anyway, for 0, it's not making any difference. You pick true or false, it will be okay. But let's put false. Okay. Yeah. So we got this value, which is same basically. Okay. If you compare this two. Yes. So same answer we got using the binomial distribution function also.
So why did we put false here?
False means I'm just looking for 1, 0 value. If I'm looking up to 15, 1 to 15, I have to put true. It will take the continuous. Because here we had 1, 2, 3, 4, 5. So I will do that also, okay, for your understanding. Equal to, again, we are doing the same thing, binomial distribution. What is the function? So my success, what I'm looking here, now I'm not looking for 0, I'm looking for all the 15. Okay, 15 trials, probability is 0.3. Okay, and I'm writing true here. So true means it will calculate for 0, it will calculate for 1, it will calculate for 2, 3, 4, 5 till 15.
Okay.
Okay,
From
so
0.
So I'm putting true here now this time. So it gives me all probability of all values, sum of all probabilities. Now if I subtract from this equal to this minus this value, I will get the answer that anyone will going to get are going to buy it. Okay, so here also, because we had got the probability for nobody buying, but we want that it could be 1 person buying, 2, 3 all. So here also we are supposed to subtract it from 1, because my requirement for f of x 1 to 15 is nothing but 1 minus this value, because this is what we have got for 0. Sorry. Right, so this is what is my answer. So I can get it directly also, or I can subtract it from 1. Got it?
Okay, sir. Yeah. Got it.
So binomial distribution function is very useful if you are using this Excel. So here what I did, because I know that the only value that is missing is f of x is equal to 0. So I can use the true function. I will get all the values, all the probabilities up to this point. So instead of all this, we will see the next part of the question where there will be some, let 1 minute, I'm clearing it and then. So what is the probability that at least 4 browsing customer will buy something during a specific hour? So now it's saying at least 4. So at least 4 means 4 people buying, 5 people buying, 6 people buying, 7 up to 15. Yes. So now this is a little more complicated here. So in the previous case, we just did for f of 0 and then we subtracted it from 1 and we got the answer. But here we have to calculate for f of 0, f of 1, f of 2, f of 3. Then we have to add it and then we have to subtract it from 1. But if you're using the Excel, it's very simple. We will just put for f of 3, we will use the true as the logic. We will get the sum of all probabilities starting from 0 to 3, subtracted from 1, we will get at least 4.
Right.
Clear? The probability of at least 4 browsing customer buying. So let me show you how it will be. So now, in this case, we are using the, just expand it. So equal to, my bad, binom dist function. So my number that I'm looking here is 3, because it's at least 4. So 4 and above are in my choice group. So what is not there is anything which is less than 4. So the highest value for that is 3. Total 15 trials. Probability is 0.3 and cumulative. That is true. This will add all the values, all the probability values starting from f of 0 to f of 3. So click OK. But my answer is, what I'm looking for is the other side of it, equal to 1 minus this value. So 0.70313 is what I'm looking for. So you can see the answer. The next. So this is what? 0.7031. Previous one we got this 9953. 9953. This is the second one. We got this value. Now, the next one, what is the probability that no browsing customer will buy anything during a specific hour? No is probability of 0 or f of 0. We have already calculated it, right? So, or you can, whatever you have got this value, subtract it from 1, you will get this answer. And yes, please, any doubts?
Got it, sir.
No, right? Okay.
Yeah.
And the last one, what is the probability that no more than 4 browsing customer? So now I want no more than 4 browsing customer will buy. So the highest number is 4. So I'm looking for the probability of 0 to 4. So in the Excel, now we can do it equal to binom dist again. I'm looking for 4. Then the number of trials are 15.3 and 0.5842. The next one. Let's see if they've got that. So 4821. So R greater than 5 we have done. So why we are getting this difference? Let me see, 515558. Oh, sorry, by mistake I have pressed 15 here instead of 15. So we got the answer same. Okay. 0.51549. Clear?
Yeah.
Sita, with binomial distribution, any doubts?
No, sir, no doubt.
Right. So this is clear. So we'll move on to the continuous distribution, and we just have the normal distribution here for discussion. So this is how, if we plot a graph of the binomial distribution, just for understanding, if your p-value is less than 0.5, it's right skewed. The tail is longer on the positive side. If it's 0.5, it will be symmetric. And if it's greater than 0.5, it will be left skew. Okay. So more number of higher probability values you will see on the higher side if the p is 0.8 or higher, greater than 0.5. If it's less than 0.5, lesser values will be on the higher side. Now, I've already said there are three types of the continuous distribution. We talk about uniform, normal, exponential, but the entire discussion will be in and around the normal probability distribution. Okay. Uniform is within that interval, there is equal chance for event, no changes in the chances, whereas normal, it will gradually go up and then it will decrease. Exponential, so it will have a higher chance initially and then gradually it will decrease. Okay. So all this is fine. Yeah. So this is what we have to remember, because we are looking for the area under the graph rather than a distinct value. So we don't call it as probability function, we call it as probability density function. This is one of the indicators which can help you in identifying or differentiating the probability means discrete or continuous probability distribution, which one we are going to use. So this is the probability density function that we use. This is how it looks like. What is the chance for a specific smaller interval within the all possible choice groups? If I'm looking for, that is the density of occurrence within that limit. So a very complicated formula, normal probability density function. You're not required to remember this. This formula will not be used anywhere. Just to show you, this is how the probability value is calculated, but because it's very complicated, so there is a simple formula. We will just come to that slightly later. So no need to remember this formula. Okay. So just ignore this. Just to show you, I have put it here. There is one reason why we convert this any normal probability distribution into a standard normal probability distribution. Okay. So what is a standard normal probability distribution? Harshita, anytime it's discussed?
Sir, I don't remember.
So the standard probability distribution function, because this probability distribution function will have a mean, it will have a standard deviation value, and those are impacted by the unit. So I can have the mean value of, let's say a very simple example, all of us we use pen to write. So the mean diameter of the pen is, let's assume it's 2 centimeter. Okay, but if the diameter is less or it's more, anything less than 1.8 or anything greater than 2.2 will be a defect because it will not fit into the gap. Yes, it will be too loose if the diameter is less. If the diameter is more, it will not fit at all. It will not go inside. So both the cases, the pen will be counted as a defective pen, right? And people will not buy it. So my objective is to ensure that the pen's diameter falls between this range. So I'm looking for the probability of what is the chance if randomly if I pick any pen will fall in this range. Okay. So, but the problem here is if I calculate this in this way, I have to use this entire thing. First thing I have to calculate the standard deviation, which is again in this unit, then the mean value, the pi value, e to the power of something. So which is quite complicated. So to simplify this, and because again, the minute I change it from centimeter to something in terms of millimeter, so this 2 will change into 20, right? So everything will change and this f of x value will again change. Yes. So this is dependent on the unit and I have to make it free of the unit. And for that reason, what we do is we convert a normal probability function or normal probability distribution into a standard normal probability distribution where the most ideal value is 0. So we are comparing it with relative to this value, either of the side. Okay, so whatever number of the standard deviation, so here one standard deviation, or let's say this is 2 standard deviation value is 0.2, right? But I'm converting this 0.2 into, this is 2 minus 2, okay, standard deviation, and this is plus 2 standard deviation, okay. Not in terms of the interval, the deviation values, okay, I'm saying between these two levels is this rather than the 0.2 or some value. So I'm removing the unit effect here. So a normal standard probability distribution function is somewhere where the mean is 0 and the extreme limits are -3 to 3. Okay, so this is between what it will deviate. So it reduces my calculation effort. It makes the formula much simpler. But how this is converted, we will not go into the depth of it. There is a table which is already there. And we will use the table and we will use a formula, which is like, so this is called as the Z distribution, okay? And normally we deal with the Z distribution everywhere. So Z distribution values will range from -3 to 3. And using this values, we will calculate the probability value, okay? So Z values -3 to 3. Using the Z value, we will get the probability, which will range from 0 to 1. So how that happens in the next slide, we will understand it, okay? I'm just ignoring all these things. This is something you can study by your own. All these are the characteristics of normal distribution. And this is a property that we have already discussed during the central limit theorem and the time when we discussed the Chavy's theorem and all that.
Yeah.
So yeah, so no need to again come with that, how much area falls at what level, because this is something which helps in converting a normal distribution into a standard normal distribution. Okay, that's why it's covered. So this is the most important formula. So the Z distribution, where we are converting a probability distribution into the Z distribution. Okay, so for that we need to know 3 values. One is the X value. X value is the positional value within the distribution. Like we had that 1.8. Mu is the mean, that is 2, and the standard deviation, which could be like 0.2, 0.4. So if we can get all these three values, we can get the Z value. So this Z value, you have to compare it in the table, and the corresponding value to this Z will tell you what is the probability of occurrence within that interval. Clear? Or what is the probability density function for that specific X value. So I will just go directly to one numerical and then we will try and understand. So this is related to a small case study about a specialty toy. So specialty toy, this is a company which is located in somewhere in US, and it gets all the toys manufactured in China. So every time when the Christmas season comes, okay, the festival season, it starts around the November, December time. It has to come out with some new toy because people will not buy the same toy every year. Yes. So this company has to place the order by July or June each year with the Chinese manufacturer, so that they get the stock by October, and from November onwards, so they can start making the sales. But the demand is highly volatile. Why it's so highly volatile? Because every time you're coming out with a new toy, so you never know that people are really going to like or dislike the toy. Yes. So will it really work? And then there is another issue, is the opportunity cost. If you think that people are not going to like a specific toy and you're placing lesser order with the Chinese manufacturer, but suddenly it picks up in the market, you cannot go and ask the Chinese manufacturer to manufacture and supply, because it takes time to ship. It's not just to manufacture, but you have to ship it from China to the different stores that you have in US. So if there is a shortage, means it's an opportunity loss. But if there is a surplus, so after Christmas, people are not going to buy this toy in that number, right? So you have to sell it at discounted price, which could be a loss to you. So you have to balance, or you have to do a trade-off between that. So you have to see that you don't pay a very high opportunity cost, right? There was a high demand, but you failed to fulfill that. At the same time, you don't want to make any losses in terms of selling the product at a discounted price, because once the season is gone, people will not buy. So very simple as the IPL t-shirts. Yes. So think about you who prints the Chennai Super Kings, right? IPL t-shirts. So there are two things. If you underprint the t-shirts, there is an opportunity cost, right? You are failing to make a sales of the t-shirt. But if you're overprinting the t-shirt, who is going to buy the t-shirts after the finals, right? And next time you don't know whether this t-shirts, the colors will remain the same or it will change. The BCCI can change the decision anytime. So that is a risk. So immediately you have to sell it at a discounted price just to recover whatever investment you have made, at least some part of it or some proportion of it. So we have to do that same trade-off here as a decision. So now there's a story. A new product which is designed for the current year, it's called as the Weather Teddy. So Weather Teddy has some unique characteristic. It can change its all those clothings based on the weather. So if it's like the temperature goes up, it can have a simple cloth. If it's a winter, it can have automatically, it can put some overcoats or something. If it's a rainy, it can come out with an umbrella or something like that. So that is the innovative product that they have come out for this season to sell. But again, how many orders you should place with the Chinese company which supplies you this toy is a question mark. So when you did market study, because you can't do a pilot study getting some samples from all the way from China to do that. So you have to depend on the historical facts and figures and various changes in the macroeconomic level. And based on that, you had 4 zones: North Zone, South Zone, East Zone, and West Zone. So you just ask the zonal heads of the sales department, and they gave you 4 different figures for the current year. Somebody said, no, 15,000 could be the sales target or sales number that you can expect for this year. Somebody said 18. A manager said 24,000, another said 28,000. So now the question is, what should be the right number? Keeping both the things in mind, that after the season, you're not going to get the sales. But if you are under ordering, means you are having an opportunity loss. So now look at the price. Each weather teddy is going to sell for $24. The cost price that you will pay the Chinese manufacturer is $16. So if the inventory remains after the holiday season, the sales price will fall from 24 to 5 unit. So 5 unit means you will make a bigger loss. So if you look at the positive side, the profit what you're making here is $8. Whereas when you have to make a loss, you will be making a loss of $11. Right? So if you are under forecasting, what is your loss? Your loss is $8. But if you're over forecasting, your loss is $11. Okay? So you have to balance between these two. So based on your forecast, so expected demand, this is the expected value, which is from the historical values that we had got, or what is the average value. So the average value is 20,000 with a confidence level of 0.95. So 95% times, if I see that of the times values, if I've combined, the average was 20,000 units which were sold. So now I want to really check what will be the demand of the teddy to lie between 10,000 and 30,000 units. Sorry, that is what is the 95% probability. My bad. So this 20,000 we have got with the 95% probability means the demand was between 90 and 30,000. Sorry, 10 and 30,000 in 95% cases with an average of 20. Clear? Any doubts in understanding the problem? So the very first thing we should do is every time we get a problem on normal distribution, we should plot it. So when I'm plotting it, the very first thing that I have to plot is the mean. The average is 20,000. And the limits means this area from 10,000 to 30,000. So if I look at this full area, I have 95% chance. Okay, or 95% confidence here. So basically this full area that is shaded is 0.95. Okay, or we can call it as 95%. The chances of getting a sales value ranging from 10,000 to 30,000 is 95% chance. Is it clear?
Yes, sir.
Yeah. So now we will go and check the next part of the question that it says. So now what we are more concerned here is what is the order range? We have already seen this order range, what it tells about it. All this is done. So, but we are looking at the stock out probability for various order quantity. So what is the chance that there will be a stock out? Stock out, what it means, stock out?
Higher demand and low supply.
Yeah. So the demand is high. So I'm just plotting it, right? One of the example. This is the probability distribution of total, right? And so this is the full demand cycle. And if I'm only able to fill this part of it, is out of the entire demand what I have fulfilled, this entire portion of what is not fulfilled is my stock out, right? So I'm only able to match this much of it. So we're looking for that probability and so on. So let's start with one by one, each of them. So the first thing what I need is I have the X, I have the mu value, but I don't have the standard deviation value, right? So the Z formula, if I have to use here, Z equal to X minus mu by the standard deviation, right? So I have the X, any of these two limits could be my X. The mean is this, that is also there, but this is what is missing. Fine. So to get this value, what I have to do is for standard deviation, X minus mu by the Z. Because I have the probability with me at this value. So for this corresponding probability value, I can get the Z value. And once I get the Z value, I will substitute here and I will get the standard deviation value. Okay. So we can pick any of the two things because one of the properties of normal distribution is each side is a mirror image of the other side. So this area, what you're seeing on the left hand side is equal to the right hand side area. So you can pick the X value as 10,000 or X value as 30,000. It will make no difference, okay? Because end of the day, we are looking for the area. So we can take it as 10,000 also. So 10,000 because it's on the negative side. So 10,000 minus, so I could have taken 30,000 also, it will not make any difference. 20,000. Okay, by Z. So now to calculate the Z, we have to go to the Z table. So just give me a minute. I'm searching where is that Z table. I hope it should be there. Just a minute, I'm searching for the Z distribution. We can If not, we will look at for online.
So what value of Z will we search in the table?
I'm just coming with you, right? Yeah, it's open. I've got it right. Just give me. What's that screen? Yeah. So basically, you can see there is a table, and this is called as the standard normal table. Z is nothing but the standard normal value. So now this gives you the area. And as I said, this is the mirror image. This part or this part, it's the same thing. So let's go back to the slide. So basically, we have to look for, because we have taken this side. So can I know what is the value of this area? Because this total is 1. Full thing is 1, right? Sum of all values in the distribution is 1. And I know this part, it divides equally, right?
Right.
So this part is 0.5. Okay. And this between these two lines, it's 0.95. So what could be the balance? 0.05 each side. So 0.05, when we divide it by 2, this side it's 0.025, this side it's 0.025. So basically what I have to do is to identify this portion, I have to subtract 0.5 minus 0.025. Okay, so this is the probability of anything falling in this range. Okay, so that's what we are going to calculate, which is nothing but how much it will come. 5.74, right? So 0.475. Yes, so basically we can round it up to as 0.48 approximately. So this is what we are going to search in the table. Okay, so that will give me the Z value. So now I'm taking you to the table now. The table, in this we have to search for 0.48. Clear? So because that will give me, because it's a mirror image, whatever is this side, the same value will be this side also. And 0.48, so what it says, this inside things, if we look at, is the probability value, and whatever is on the outside, which is highlighted, is the Z value. So I have to look for what I got, 0.48, to get the Z value. So search for, or 0.7475, right? So that's what we had. Look for that, and I got this 0.475 here. Yes. So this is what is 0.475, exactly what I was looking for. So the corresponding Z value for it is 1.9. Okay. And if you look at the top, it starts with 00, 01, 02, 03, and so on. So basically you can remember it also. This is a standard number. It's 1.96, but we will see. So 1.90, 1.91, 1.92, 1.93, 1.94. 1.95 and 1.96. So 95% chances means the Z value is 1.96. There are some standard things. Okay. So probably you can remember it also. If not, you can use the Z table. In the exam, it will be provided to you. Okay, don't worry. So the Z value that we were looking for here was 1.96. Clear? So now, when I put that 1.96 in my calculation here, so you're calculating the Z. So we use this formula, okay? Z equal to X minus mu by sigma. So this is the formula that you should remember. So sigma, if you take it here, because I want that standard deviation. So X minus mu by Z. So what is my X? X is 10,000. My mean is 20,000. Divided by 1.96 that we got from the table. I will show you how we can do it in directly also on the Excel. But if we do the calculation, this is minus 10,000 by. So you can ignore this minus sign. It's only on the left hand side because we are looking for basically a deviation which is equal on either of the side. So minus 10,000 by 1.96. So how much we will get?
102.04.
Perfect. So that is what is my standard deviation. Okay.
Standard deviation will always be absolute value regardless of sign.
Yes. So you can ignore that decimal. Yeah. So 5102. Clear? So 5102, I got my mu here. I got my standard deviation from this calculation, which has come to 5102. Now for each of the cases, we have to find what is the stock out probability chance. So where my X value is changing, this mu and this is fixed. So mu is 20,000. My standard deviation is this. So for all different X values, we will calculate the Z, and based on the Z, we will try to look for the probability values. Okay, so let's start with the very first one. Or let's go this straight. The very first case is 30,000. So 30,000 minus 20,000 by, oh sorry, we have done the calculation here. This is not the case. Yeah, for 15,000, when we have the option of 15,000. So let me just clear it out. So in 15,000, we got the Z value as minus 0.98. Okay, so now we have to find what is the probability of stock out. So for that reason, the very first thing we have to plot. This is my normal plot. So this is what I'm looking for. That is 20,000. And now if I'm fulfilling only this much, okay, that is 15,000. So I'm asking for what is the chance that there will be a stock out. Okay, so what part of it I have not filled? I have not filled this part, this full thing. Obviously, there is a 0.5% of stock out because this part is not covered, full thing. And now I have to find this part, which is uncovered from the Z table. So this 0.5 is already known to me. This value we have to search in the table. Okay. For searching that, we have to look for the Z value of 0.98. So 0.98 in the table. Okay. So Z equal to 0.98. So 0.9 is here. 0.90, 0.91, 0.92, 0.93, 0.94, 0.95, 0.96, 97, and 98. So this is the value that we have to add to the this is the value of Z is equal to 0.98. So this is this area. Okay, and this area is 0.5. So whatever I am missing is equal to 0.5 plus 0.3365. So 365 will come as it is, and 0.8. So this is what is the chance, 0.8365. Okay, so 83.65% chances are that I will not meet the demand if I am keeping a stock of 15,000. Let's see that if the same thing we have got here. Yes, so 83.65. So when we increased it to 18,000, Z is equal to 0.39. Let's see what is that 0.39 value says here. So further up. So 0.39 is this value, 0.1517. So you have to add 0.5 plus 0.1517, which is coming to 0.6517, right? So 0.6517, 65.17% chance of stock out, 65.17. So now we have increased. So now this time it's more than 20. So we will not add 0.5. Rather than that, we have to subtract it from 0.5. So why we are subtracting it from 0.5? We will see it in the drawing now. So now you have to see where exactly this 2,4 is lying. So this part is where 20,000 and you're maintaining a stock of more than that, that is 24,000. So you're maintaining all this thing, right? So what is the portion that is the stock out is this part. So how to get this part? Because the Z table will give this part, this reason. And if I have to calculate this reason, I have to subtract this from 0.5. Same thing we have done, 0.5 minus this. So whatever you're getting as a Z value. So look for the corresponding probability value and subtract it from 0.5. You will get this part. Let's see that. Are we getting it, the same value? So, sorry, I just missed out. What is that? 0.78. So 0.78, we have to search here 0.7, 0.70, 0.71, 72, 73, 74, 75, 7678. So 0.5 minus 0.2794. That's what we have to do to get the value. So this value will be 0.5 minus 0.2794. So 6, 0, 2, so 22.06% chance, right, of stock out in that case. Let me see if I've done it correctly. 0.78, 2823. 1 minute, let me just have we looked for some wrong value. So we're searching for the value of 0.78, right? 0.7071727374757678. Oh, sorry, 7778. My bad. It's 2823. So 2823 this should be, and so this is the value, right? 0.7 and 08. So by mistake I stopped here. It's 0.2823. That should be taken. That should be subtracted from 0.5. So this will be even lesser than approximately 21% chance. Okay. And further, the last one. Same way we have done it here also, 1.57. We have just searched for that. It came to be 44.18. So very less, 5% chance of stock out. Yes, so whatever we have done here, if we want to do it using the Excel, right? So norm dist function from the very first one here. Right, so if I want to calculate this value of the probability at 15, so I know what is X, I know what is the mu, I know what is the standard deviation. So let me open the Excel, new sheet. So we have a normal distribution function. This norm dist, you can use any of the two, norm dist or norm dist, but go for the norm dist. Click on f of x, look at it. It gives you the x value. So what was the first x value we had? Let's check here. 15,000, right? So x is 15,000. Then the mean value. What is the mean value? 20,000. The standard deviation 5102. So here, obviously, it's a cumulative distribution. If you want a specific value on that point, then you will say a false. Otherwise, you have to tell it true. But here, you will get a different value than what we had got. I will tell you why you are getting a different value. So we got this value as 0.16354. So we got the direct probability value. So yeah. So what happened here? We took this value, we took this value, we took this value. And what we have got here is the different value why we got there. is, I'm just showing you with a figure how the function works. Okay, the Excel function will always give you the area from the left, this area, but basically we're looking for this area. Okay, so what you need to do here, whatever you got as an answer in the Excel, you have to subtract, equal to 1 minus this value. 83646. Let's see if that is the answer. 8383646, right? Approximately. Got it? So that's, you have to remember when you are using the Excel versus the table. Table will give you this side value. Means table always gives you the deviation from the mean. Whereas the Excel will always tell you the area from the left to the right. So you have to plot this entire graph first, and accordingly you have to understand. Fine. So the next one, this 24, where the value is on the other side. Okay, so this is 24. Again, I'm looking for this area, but I will get this value. So we have to subtract it from 1. So let's do it one more. So equal to norm this function x is 20,000 minus, or sorry, 24,000, my bad. 5102, and it's cumulative. So for cumulative, we have tried to. We got this value. So why we have got this value here, 0.21, and if you look at here, we have got the same value. Because this is on the higher side. Okay. So it gave you directly this side value from the other side. That's the beauty of this tool. If it's on the lesser side, you have to look at this part. It always talks from the extreme side, because here we're looking for the same area and the tool. It never compares with respect to the mean. It talks about the remaining portion, and here in this case, it gave you the same answer in one single go. Where is that Excel sheet? The same value. We got 21652. The same thing we got here. Approximately very close to that. Okay. So you have to remember that the software gives you the values which is outside this range. So either it will give you this side value or this side value. You can take the mirror image of that. So it will not give you more than 0.5 as a value. So it will give this corner value or this corner value based on your requirement. You have to do the calculation or adjustment. Clear, Harsita?
Yes, sir.
Fine. So now this is done. Another important topic. Have you studied about the alpha error, beta error, the type 1 and type 2 error?
I've heard of them, but
yeah, so that is again something which is important from the exam point of view. So we'll discuss this. So every tool that we use or we develop, right, for prediction. It gives you some prediction, more specifically something which is a machine learning algorithm that we develop, like the binomial algorithms that we have, success or failure kind of thing. Okay, so when we do a test or when we develop a model, let it be a logistic regression model or decision tree model, to predict a consumer behavior based on some parameter, whether he is going to buy or he's not going to buy. So there are two outcomes. Okay, so if the tool says that he's going to buy, but actually he's not buying, so it's a false positive. That is an error. Tool said he's going to buy, but he's not buying. Okay, and then the tool says that he's not going to buy, but he's buying. It's a false negative. Both false positive and false negative are error. So one is a type 1 error, the other one is the type 2 error. So the type 1 error, when you will do the hypothesis testing, when you will try to develop the relationship. So when you are saying that X is successfully, it's predicting Y. That's what the tool has said, right? So the chances, like I will give you a very practical experience of mine. When we were doing a Six Sigma project, okay, long back, some 20 years back, in Bharat Electronics, where there was a problem with respect to the welding, and a lot of complaints we are getting from Indian Army. So we had to run a Six Sigma project to identify the root causes. And we got multiple root causes through brainstorming, through different experiments. So one of the root causes that we went ahead with was the operators who are doing the welding. They are not sufficiently trained or experienced, because we had a lot of temporary employees who were doing the welding because of the shortage of manpower. And we assume that because those people were less experienced, this error is happening. That is one hypothesis that we did. So we replaced them with the most experienced people, but there was no difference in terms of the defect. So now what happened here? We assume that that is a cause, a root cause, but actually that was not the root cause. There was something else which was a cause. So I will come to that. So what error we did? We established a relationship. Okay. But at the same time, we ignored some real things which were related to the machine, precisions, testing, and the reliability tests, and so on, which were not properly carried out, but nobody really pointed out that. So that is the type 2 error. We failed to identify the real cause or ignore that as a cause. Because somebody said that this could be a cause, but we say no, that can't be. And we came with a cause which is not the real cause or not a real root cause. Got it? So we have to develop a model which prevents you from both the kinds of error. It should not give you a wrong X. At the same time, it should not drop a right X. Okay, for predicting Y, it should pick all the X's which are correct. So there should not be any X which is a good predictor of Y is missed out. At the same time, we don't bring any X which is not a right predictor as a predictor variable. Clear? So now the question is, out of the two errors, which one is more critical or more problematic?
False positive.
False positive, which is the beta error, right? Or no, it's the type 1 error. There was no relation, but you are saying that there is a relation. Yes.
Mm.
So very rightly said, because in the law also there is a statement, right? So 100 गुनेगार चाहे रिहा हो जाए, एक बेगुनाह को सजा नहीं होनी चाहिए, right? So somebody who has not committed the crime should not be put behind the bar or should not be punished, even though 100 culprits or 100 criminals are left or they are not put under the bars or somewhere. So that's how the world goes, but the machine learning algorithm is not like that. So when you're doing a business, think about, you are targeting to a wrong customer, that's fine. But if you're missing out a right customer, which one is more loss making? You get an ad, you are not interested in that product, you will just simply ignore. But somebody who's interested in your product, but he's not getting that ad reaching to him.
Yeah.
Right. So we cannot say that which one is more critical in what context. So both of them, they have their own implications. So we have to balance between both of them, right? So one place we call it as sensitivity, and the other one, I think specificity or something like that. I'm not getting that. So when you will do the machine learning algorithms, when you will learn, so that time you have to do this. You have to check for both the errors, and then there is something called a statistical power. Statistical power is the strength of your model to correctly predict the type 2 error. Okay, so these are what it is in terms of basic definitions. And this is the last thing that you should remember for a longer term. As you will progress through this course, you have to apply different tests. So what test you should be using based on what kind of variables, right? This is what it talks about. So if you're dealing with a univariate, so where there is no y variable, you're just looking at the features of x, only one variable that you're testing. The best suited tests are t-test or chi-square test. CHI means chi, okay? And then when you're dealing with two variables, okay, but these two are somewhat related. So what are the relations here? Like if you, somebody is talking about the healthcare, some kind of lotion or some body massage or something they are saying. So if you use this, if you go through this treatment, you will get this kind of benefit. So there, the data is related. Oh, sorry, I will just stop here. So fine, Harsita, I'm just you can take the exit. I'll just complete this discussion, and I will also stop. Fine. So because this was the last.
Sir, just to reiterate, the important topics are probability.
Probability is one important topic I'm telling you. Then the regression, correlation regression, that is again another important topic. And focus on the descriptive statistics. Okay, so that is another area that you can expect some questions coming.
And numerical to theoretical question ratio is 1:3, 1:2.
Yes, 1:2. Okay, so keep that in mind. So based on the question bank, how they pick the questions, that might slightly change, but there is a combination of theory and numericals. Okay.
Okay.
And higher chance of getting a theory question than the numerical.
Okay. Okay, sir.
So just remember the application side of all this. Okay. So remember the application of the probability distribution, remember the application of regressions, correlations, the descriptive statistics. So focus on that because you have to explain it with regards to some examples. And if some problem comes, I've told you what can be done with that. Okay.
Okay. Okay, sir. So, sir, I'll take an exit. But
Yes,
if you
please.
continue explaining, I'll refer to the recording of this.
Right. Please. Yeah, sure.
And sir, please share this slide
I
deck.
will do it. Yeah. Tomorrow I will just ask the coordinator to upload it in the portal.
Okay.
So, okay
Thank
then.
you so much.
Yeah, see you and all the very best for your
Yes.
term and exams. Good luck and good night.
Thank you.
Fine, just to complete this part, because the only student who was there in the class has already taken the exit, Harsita. But I just want to finish this before we call it for the day. So the first thing is we cannot apply any statistical technique to any kind of the data. So we have to be very clear with what is the data that we have in hand. So the data could be a univariate, so only one single variable, so we can't compare them with respect to another variable like 1x and 1y. Here, either this is a x variable or y variable, and we're just trying to see the deviations or the trends in that particular variable. So there are a couple of tests that we have to remember, and based on the type of data, metric data, which is measured on a ratio scale or an interval scale, are metric data, which is a nominal data, or ordinal data, that is a non-metric data. Okay, so if it's interval scale data or a ratio scale data, and there is only one data set that you have, or one variable at one time period, we can go for a one sample t-test. There are multiple types of t-tests that you will come across. And if it's a non-numeric data, something which is only having the frequencies, which doesn't have a unit with that, so we have to use the chi-square test for that. Now we have the data at two different time points. Okay, so the data is related. As I said, the same set of people who have come for some medical treatment, pre-treatment and post-treatment. If you want to see what is that change. So here we are dealing with the same variable. We're not having one x and one y. It's x at two different time periods. So if it's a metric data, we will look for the independent sample t-test. So where we are seeing that whether there is any kind of relationship between the two samples that we have got, pre and post. Is really this treatment or the intervention has brought any changes in that? Okay, or not? Fine. So if it's a non-metric, again, we can have the chi-square, we can have Mann-Whitney U-test. So normally this Mann-Whitney U-test could be used for non-parametric kind of data, where the data is not normally distributed. Okay. Sorry, that was for the related sample, what I was talking about, the paired sample t-test, because the samples are related. But when you're comparing somebody's height with respect to the weight and so on, so those are independent samples. Okay. So there we can have, again, both are x variables. So we cannot say that height is leading to the weight or weight is leading to the height. So there we can have the independent sample t-test, or for metric values, if it's a non-metric, we can have the chi-square test. So chi-square test is a very powerful non-metric test. So chi-square test can be also used for metric data too. So whenever the data is skewed, we don't go for the Z distribution or t-test. Rather, we go for the chi-square test. So just remember that. And when you in future, we will deal with a lot of multivariate techniques or multivariate data. So there we have ANOVAs, ANCOVA, multiple regression, logistic regression, conjoint analysis, discriminant analysis, something called as logistic regression, canonical correlation, and many more, right? So the decision trees, you will have a support vector, machines, and random forest, many tools you will learn in the future, and most of them are the multivariate techniques. Okay, so with that, I'm just stopping here, because there was another topic which was related to the confidence interval, point estimation, more related to the sampling distribution, but these are slightly less important from the exam point of view. So that's where I think we can stop without doing that. So obviously, if you have any doubts, anybody those who will look at the recordings, please reach out. We can. I will try and share some reading materials if required, or if you have any doubts, I'll try to address them online. Okay. So then this the last part. This you can ignore from for the exam point of view. The confidence interval to estimate of proportions. So proportions are again where we use the binomial form of the distribution as a sampling distribution. So, but again, this is something which is not really part of your curriculum, but for understanding in future, you might come across a lot of such scenarios where you will deal with the proportions rather than the full intervals. Okay, in a sampling distribution. That's why I've just given you this slide, but you can ignore, right, in the when you're preparing for the exam. But for your future, this could be a useful slide too. So with that, I'm wishing you all good luck, right? Obviously, in session, I'm not finding any of you, but definitely I'm quite hopeful that you will look at this video sometime later. So anywhere after going through this session video, if you find anything which is difficult to understand or slightly complicated, please feel free to post it using the post my query segment, and I will try and address that. Okay. With that, I wish you all good luck for your exam. Do well. And I've already said what are the important things that you should focus more for preparing for your exam. So just target those things first. But having said that, don't ignore other areas also, because data will come or the questions will be from a question bank. So there is always a chance of something coming from the ones which I have not highlighted as important, but there could be a chance of getting that also, right? Because we discussed probability. So what I said in the class are the topics which holds a higher probability, but there is always a chance of other topics also to be part of the term and exam. Okay, then good luck. See you. Bye-bye to everyone.